This is a picture from last summer. It's similar to the one on the back wall that I had printed, only this one actually still, it has a logo of a company, so I didn't really want to print this one. It also, I like this because it has some of the balloons that it already launched, but if you look over in the right side of this image, you see that it's a little bit crunchy, for lack of a better word, because there were kids that were throwing pebbles in the water when I took the picture. And so it made ripple effects in that picture. I did. And that one too. All the pictures in here I took. I did. Okay. All right. So I want you to focus on two parts, and it's hard to focus on two parts at the same time. So we're going to look at the top right of your doodle notes, and it talks about the definition of a reflection. A reflection is a transformation that uses a mirror to reflect a figure. And that mirror is called the line of reflection. So the shoreline in that picture was the line of reflection. Let's wake up. Corey. Okay. Okay. The bottom left says that a reflection in a line M maps every point P to a point P prime, so one of these two properties is true. Okay, so I want you to pay attention to this one. What do we notice? Corey and Vinny, wake up. Okay, pay attention please. Eyes up here. Okay, what do you notice about this piece of this drawing? I like that. It's perpendicular. Okay, so the P is going to be P to P prime. That segment is going to be perpendicular to our line of reflection. It is the upside down T. Okay? And when you also look at this, do you notice the little tick marks? They're the same distance away, aren't they? So they need to be on a perpendicular the same distance away. Okay? Now here's the special case. I want you to put a star or a note or something to draw your attention to this. If P happens to be on line M, then P is the same as P prime. It has nowhere to go. It can't be reflected. It stays on that reflection line. So put a little star or something to remind yourself that if P is on the reflection line, then P prime and P are the same point. So you just write a P prime next to the P and you're good. Does everyone see that on your sheet in the bottom left corner? Okay. All right. Any questions on this part of our doodle notes? Okay, next one. So this is the big portion of your notes. And this first pre-image, to use the information that, or the vocabulary that we used from yesterday, is triangle ABC. So that's where we started. That's our before. And I made it reflect across which line? The x-axis. So write x-axis in that blank. Corey and Vinny, write x-axis in that blank, please. So reflected across the x-axis. And the distance from each pre-image point to the x-axis is the same as the distance from the x-axis to the image point. So notice that C is one step away from the x-axis. So C prime is one step away, as is B and B prime. But notice that A is up here 4 steps away from the x-axis. So A prime will be 4 steps away from the x-axis on the opposite side. Okay? Good. Now, what happened from here is we took this image and we reflected it across where? The y-axis. So put y-axis on your blank. And that means that since B prime was 2 steps away from the y-axis, B double prime is now 2 steps away from that y-axis. C prime was 4 steps away from the y-axis, so C double prime will be 4 steps away. And lastly, A prime was 2 steps away, so A double prime will be 2 steps away. Does that make sense? You have to be the same distance away on the perpendicular. Okay? What questions do you have about this piece? All right, we're feeling good? Yep. So we just count. How far was it? Make it that far away. Okay? Does that make sense? All right. So the next part I want you to focus on your drawing is this little box up here toward the upper right. Okay? Upper right. It says graph triangle ABC with vertices A 1, 3, B 5, 2, and C 2, 1. So we're in this little box right up here. Okay? Corey, graph those for me, please. So we're in this box right here. Graph those 3 points. Give me another hand up. What's going on? What's going on? All right, so you've graphed ABC. Now I want you to draw line Y equals 3. So we have our ABC graphed. Where's Y equals 3 at? Yep, this is the little tiny one in the left side. Okay, we want a line where Y is equal to 3. Is that a horizontal or a vertical line? It's a horizontal line. So we go up here where Y is 3, and we draw a horizontal line like the horizon. And let's make it dashed so we don't confuse ourselves as to where the axes are. Okay. So we're going to dash this line. And this point, and this point are going to be reflected across that line. So when we reflect it, where does A go? It stays put, right? Because it's on the line. So rename it A prime. It's not moving. Okay? Now, remember, we need to go perpendicular from this line. So we want to go straight up. So B is how many units away from that 1? So we want to be 1 up. And name that B prime. And C is how many units down from the line? 2, so we want to move 2 up from that line. That's the one they chose. They said that this is your reflecting line. Okay, they just told us. Normally, before we did across the x-axis and the y-axis, this time they said y equals 3. Okay, so now we have our new triangle. And it should look like a mirror image of the other one across the line y equals 3. Okay? Questions on this one? Okay. All right. So here comes the next one. All right. So now we're talking about line AB or segment AB, and this is the one down toward the bottom right. Okay, so we're down here toward the bottom right, and we're asked to graph segment AB. Okay, so this is the portion of your doodle notes. And we want to graph segment AB with endpoints A is at 3, -1, and B is at 3, 2. So we're at 3, -1, 3, 2. We draw our segment. And this time, they want us to translate or reflect that across the line y equals x. So y equals x looks a lot like y equals mx plus b that we learned last chapter. What's our slope? What's the understood number in front of the x? 1. Our slope is 1, but we have no b, right? Our b is 0. That means it's going through the origin. So it's going through 0, 0, and it has a slope of 1. We're rising 1, running 1. Because if y equals x, then 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. will be on that line. As is -1, -1. So dash your line, that's your reflecting line. Okay, This part, you're okay with the sketching of the points, okay? Now this line y equals x is a little different. We haven't dealt with it a lot. It's not the x-axis or the y-axis. So now we're saying, how are we going to graph this line? So we have a reflecting line, okay? So when I learned these, all I did was I said, well, if y is equal to x, I'm going to let x be 1. That means y has to be 1. And x is 2, y is 2, x is 3, y is 3. So that's my dashed line that we're going to reflect across. Okay, so we haven't reflected yet. All we've done is graphed a segment, right? And we've dashed a line. Exactly. In this case, they told us this is our reflecting line, right?
Okay, so that means on the other side, the point would be 1, 2.
Right. So now when we move these, watch what happens. Okay, this, we said that we have to be perpendicular to this line, right? Okay, it was easy when it was the x-axis or the y-axis as we went up or down or left or right. But perpendicular to this line, this is why we talked about this last chapter, what's the slope of a line that's perpendicular to 1? What's the slope of a line that's perpendicular to 1 over 1? 1, but we have to flip it and we have to change the sign. We have to make it negative. Okay? So we want to go in this direction. We want to have a opposite diagonal. So if B is here, where is B prime going to be? There. Does everyone see why? It's a half of a diagonal away, so we need to be the other half of the diagonal away. This is your B prime. Okay? Does everyone see where that will be, the mirror image? Now, how about A? How many diagonals away is A? 2. So where will A prime be? -1, 3. If I draw that segment, do you see that that is a mirror image across? If you fold it along, if you fold it along that line, y equals x, these two should overlap each other. And try it on your paper. Once you get them graphed, fold your paper so that you can along that line y equals x, and then look into the light. And you should see that line, those two segments overlap each other. Okay? All right, questions on this one? All right. So the next one. Now I want you to graph triangle ABC with vertices 3, 2, 6, 3, and 7, 1. So it's the big bottom graph on your doodle notes. So graph your triangle. And notice that these guys are now not by ones, right? I needed more space. So every 2, so halfway between 0 and 2 is going to be 1. Okay, so we're in that bottom group. Graph A, B, and C. A is the point 3, 2. B is the point 6, 3. And C is the point 7, 1. Right down here. So graph A, B, and C. Down here. A is the point 3, 2. So we get this little triangle that looks like that. Then we're doing two things. We're going to do a glide reflection here. So a glide reflection means that we're translating and then we're reflecting. And that translation has to be parallel to the line of reflection by definition. So we're down here. Nope. Yep. We're going to do a translation first and then a reflection. This was a reflection and a reflection. So this is going to move, slide first, and then reflect. So translations or slides, we're going to slide, and then we're going to reflect. Okay, so where are we sliding? X, Y, here's our rule. Our rule says that X, Y is moving to X, Y minus 6. So what's happening to X? Nothing, it's not changing. The X is staying the same. But what's happening to Y? Subtract 6 for every Y, or move it down 6, right? So we're moving every point down 6. And then labeling them A prime, B prime, C prime. Moving it down 6. And remember, these lines are by 2s, so count by 2s. So because we slid down, we did a translation. Sliding down 6 means that we didn't change the orientation at all. It should look the same, just move down. Now, the second part of this glide reflection says that we're reflecting in the y-axis. Which is the y-axis? Ryan, please. Drew, which is the y-axis? The up and down axis. Okay, so we're reflecting across the y-axis. Okay. So how far away was A prime from the y-axis? 1.5 by this, right? So a total of 3. So we're moving that far. There's our A double prime. That's its new name. It's like, yeah, instead of an apostrophe, it's a quote. Okay, 2 apostrophes. It's okay. Look at your B, at your, they will be the same size when it's done. Okay? How far away was B prime from the y-axis? 6. So the other one will be 6 as well. We don't change height. And how far away was C from the y-axis? 7. So it will, C double prime will be 7 from the y-axis. So it should look like a mirror image of A prime, B prime, C prime when the y-axis is our mirror. Okay? Questions on this one? Okay. So last one. I have some different figures, some polygons embedded in your drawing. And I want to know how many lines of symmetry we have. Okay. Lines of symmetry. In other words, how many ways can we cut those and have the same thing on either side? How many mirror images, mirror lines can we put in there? Lines of reflection. So if we look at this first one, Ryan, do you see a line that I can draw that's going to be a mirror image on both sides? One going where? One going horizontal and one going vertical through the middle. Okay? Does everybody agree that if I went like this and folded it, I would get the same thing? And vertical. Now, let's think about the diagonal. If you're not sure about the diagonal, I want you to fold it. Okay? Fold it along the diagonal and see if those two match up. And they don't. Okay? The diagonals won't. So there are only 2 lines of symmetry here, vertical and horizontal. Because when this folds across the diagonal, it's coming over here, and this one would go up. Okay? Okay? So one vertical, one horizontal, no diagonals here. And you can fold it and look at it in the light to see. Okay? Next one, what do you think? One down the middle. Okay, I agree. Horizontal. That's 2. Okay. Diagonal, that's 3, because if we can go from point to point, we better be able to go from vertex to vertex. That's 3. Other diagonals, 4. But if we could go through the top and the bottom, then we should be able to go through these 2. Yep, through the sides, bisecting the sides. So try it. Fold it diagonally and see if you can see it through the light. So that's 6 lines. A regular hexagon will have 6 lines of symmetry. Okay? How about this last one? Only horizontally. So just 1. Everybody agree? Okay. Your assignment is 2 pages of your student journal, pages 101 and 100, 100, 101, just 1 through 12.